All right, let's go ahead and talk about how to make these histograms by yourself from scratch, because there are some things that you have to think through as you go through them. So, first of all, we have this information of the Unit 2A quiz. So, these were some actual scores. And so, what we have here is the data. And when I want to do my graph, I need to know, okay, what is the range of, like, where are these data points? What is the domain? What is happening? So to get started, then I just determine the range of the data. So I take the highest, I find the highest, I think it was 96, and then I subtract away the lowest, which I think was 90 or 31. And so then after I do that subtraction, then I know what domain I'm dealing with. Okay, and so I did that over here. So the range that I have is 65. So then you want to make about 5 to 10 bins that you put numbers into. So if I'd say, okay, I want to, what's something that goes easily into 65? That's numbers 5 to 10. Well, 5 goes into it. So if I divided by 5, then let's see what that would leave me with. So if I divided by 5, then that's going to give me 6 to 7 bins. So my first number is 31. I'm going to start at 30 and I'm going to go by fives. Okay. So that's the thought process that you go through to decide how you are going to do your x-axis. So let me show you what that looks like. So you want to make sure that you label what the context is down here. You can put railroad tracks on the x-axis, not on the y-axis. If you put railroad tracks on the y-axis, you then violate the area principle and you may make a misleading graph. So here I'm going to jump ahead from 0 up to 30, and so I'm going to skip all that space in between. So I've got 30 to 100, and I'm going, oh, I guess I decided to go by tens. Okay, so I went by tens. Oh, yeah. So I divided by 10, and I'm starting at 30. Okay, so this is going to make me 67 bins. Now, I don't know how I want to do the y-axis labeling yet. So I have to see how many what's the bin with the largest number of items in it. So then I come over here and so I start going ahead and figuring things out. So I see from 30 to 40, I'm going to have 31 up to 40, not including 40. So that's important. That's actually a very important thing to note. If I had the number 40, then it would go in the bin to the right because this first bin is 30 up to, but not including 40. This second bin is 40 up to, but not including 50, and so on. So I color coded mine, and you can just knock them off, whatever. So I had only one item in that first bin, and I had only one item that was from 40 up to 50. That was this purple one right here. Then I had only one item that was 50 up to 60. Okay, but now I start getting some multiples. I had 3 test scores that were 60 up to 70. See, there's 3 of them that are actually 60. So that the ones that are actually 60 are going to be in this bin here from 60 up to 70. Okay, and so on. And then I counted the ones from 70 up to 80, 80 up to 90, and 90 up to 100. Okay, I didn't put the dots, I just went ahead and put the numbers. So since I see that my largest number is 20, then and I know that this grid has 20 items, I decide I'm going to go ahead and just go by ones. So I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I label my y-axis. Now, this represents the frequency, the number of students that had those scores in those bins. And then once I get all that labeled, I go ahead and I make the bars. That's how you make a histogram. Okay, so once again, determine the range of your data, high minus low. What is this spread? So I'd need to decide how I'm going to do my x-axis. And then you want 5 to 10 bins. So divide by 5 up to 10, however you want to do 5 to 10 bins, something that goes even into it. If it's something that seems dividable by 3, if you go from 0 to 12 or whatever, 0 to 3, you may divide by 3. Well, no, you wouldn't want 3 bins. So divide by how many bins you want. So there we go on that. Now, let's take a look at these pictures here that we have. These are all dot plots, and we're just kind of look at them and see what are some interesting things, because this was something I found when I was doing dot plots. There was quite a bit of confusion. I was even confused. How are dot plots labeled, and do I have to go by ones and all that kind of stuff? So, it's pretty there. So I found a wide variety of dot plots. So here's one that obviously the data is only in tens, 20s, 30s, 40s, 50. Now, I don't know if these ones that are above the 10 represents tens, 11, 12, 13, 14, 15, 16, 17, but that would not be ideal. Dot plots are supposed to indicate the individual value. So keep that in mind. Here, down here, this is maybe the closest to representing individual values. So I got, meters. This is 2.0. This looks like they go, you can kind of do this 1, 2, 3, 4, 5, 6, 7, 8. I don't know. See, even with those, can I tell 2.1, 2.2, 2.3, 2.4, 2.5, 6, 2.7, 2.8, 2.9, and so on? No, I don't know. It's challenging. Now look at this one here. Here the bins go from 15 to 20. Now, but look at what's in between there. All they're doing is just kind of stacking something in there. 61, I mean, what is this number? 61, 62, 63. I don't know. Are those both 64s? Are these both 63s or 2s or something? I don't know. So be careful with your dot plots, because technically, if this is a dot plot, you are supposed to tell the individual values of the data. So keep that in mind as you are making your dot plots. All right, so that's the end of this video. I just wanted to add that component of going through, making a histogram, and taking a look at some of those dot plot issues. All right, so good luck to you on your assignment.